Today we're going to be discussing scatterplots, and scatterplots are a type of graph where they display two sets of data. And so what we're going to be doing is we're going to be looking at how the data relates to each other. And this is called a correlation. So let's look at the first example. You're going to see in this graph we're comparing the husband's age to the wife's age. And in general, the data points go up. This is called a positive correlation. So once again, in general, as the husband's age increases, so does the wife. Both data points are getting larger. Now let's take a look at another type of graph. This is what's called a negative correlation. And as you can see, the data is generally going down. And what this means is there actually is an inverse relationship. As the X increases, the Y decreases. So a good example might be like your grade on a test. So let's say that you there's a test that has 8 questions. So this would be your math grade. And the higher the math grade is, then what happened is you spent less hours playing video games. Whereas the lower your math grade is, you probably spent more hours playing video games. The higher your math grade is, the less time you spent playing video games. So that would be considered a negative correlation. The data trends tending to go down. Now let's take a look at another one. The data points on this scatter plot are all over the graph. If they're all over the graph and you notice that they generally don't increase or they generally don't decrease, this is called no correlation, which simply means that the data points aren't related to each other. So in this case, the graph is about quality of a product versus its price. So typically what this graph is saying is that the quality of the product might be pretty good or it might be bad, but in general, the price of it changes. It doesn't matter. So no matter how good the product is, how good the car is, how good the pair of jeans are, the quality of the jeans or the quality of the sweatshirt, the price is irrelevant, unrelated to it. Okay, and then the last one. The last one you're going to see is a constant correlation, where in general, as the X increases, the Y pretty much stays the same number. So a good example would maybe be like temperature in the month of July. So let's say that based on the day, the temperature pretty much stayed at a constant about 85 to 90 degrees. So as you can see, even though we go through days in July, from the beginning of the month to the end of the month, the temperature is pretty much staying the same. That would be a constant correlation. Now let's take a look at the next topic, which is called a line of best fit. And in a line of best fit, what we're doing is we're saying that we want a line that can be drawn in the middle of the data to best represent the data. So if you are going to draw a line of best fit in a positive correlation, then your line of best fit is in general going to cut through most of the data going up. And if you're going to draw a line of best fit for a negative correlation, then the line will represent a majority of the data, of course not all of it, but most of it, remember these are just generalizations, and the line will generally go down. And then if you are drawing a line of best fit for a constant correlation, then your line of best fit should be horizontal.